I. So we'll want to continue our differential equation class. Now we're told to find whether the differential equation that we have here is a kind of a separable variable, separable or not. Okay, of course, from what you're saying here, let me just, without even solving it, I can use just my eye. If you take this here, this dx here, obviously you'll be having something like dy dx. So this is going to give you dx here and g of y. So we know that a situation like this, the x is affecting everything here. So there's no way you're going to separate your y, g of y to come here and f of s to come separate. So you might have to do all of the various maths. If you make this subject of formula, it's not going to be possible. So because you cannot explicitly separate the y expression, and neither can you separate explicitly the x on its own, it is not going to be a differential equation by separable variable or variable separable. Okay, so it means that we cannot use it. So it is not. The answer is that it is not. No matter what I want to do here now, it won't work. So if I'm to isolate this now, it will not work. If I'm to isolate this, it will not work. So that takes us to number 2. So for number 2, we have our dy dx equals x plus 1 and 2y this. So this one is easier. So we can cross multiply. And so we have dy 2y here. And then we have dx and dx here. So x plus 1. So what's the next step is to take the integral of both sides. So if we take the integral of both sides, then you integrate. So you can integrate these two with respect to dy. It's going to give me 2y. You can integrate y with respect to dy. That's y squared divided over 2. Same thing applies here. This is going to be s squared over 2. And differentiate this is going to be x. So you can put your plus c. So we can leave that as our final answer. So my final answer is 2y, y squared divided by 2 equals to s squared 2 plus x, then plus c. So I'm sure this is so clear. There's no ambiguity in that question. It's very clear. Okay? So I'm going to put in more questions. I'm sure there's no issue with this. So let's solve more questions. So question number 3. In question number 3, let me bring in more question. This question says, solve the following differential equation dy dx 6sy squared (125). So here's another question we are asked to deal with. And dealing with this question it's important we look at it critically, because as long as we can separate the variable, so we will use separable variable, but this is different from the last question we solved. So please, let's look at it quickly. So we have dy dx 6y squared, right? So I'll find a way to cross multiply. So I'm going to have, what am I going to have now? So I'll have dy y squared, and here I'm going to have 6x dx. Yes. So in other words, this is the same thing as saying dy, and then you have this. I just took this up from the law of indices. So I can apply my integral on both sides, and then when you integrate this, you have minus 2 plus 1, minus 2 plus 1. When you integrate this, you have 6x squared divided by 2 plus c. So that I'm having minus 1 over minus 1 equals to 3x squared plus c. And the implication of this is that this is the same thing. Please do not, no, this minus is not there. So this is the same thing as saying minus 1 over this. So that you have 3x squared plus c. Yes, this is allowed. So this from law of indices 1 over x, and this minus sign is over here. So, but they gave us a condition. The condition is my x is 1 and my y is 1 over this. I can put this here, and if I put 1 over 25 in this y side, it means that I'm going to have 25, the reciprocal. So x is 1, so you have c. So that I have 25 minus 3c. C is minus 28. So if c is minus 28, go back to the place I finished my solving. Look at it here. So what is c? C is minus 28. So I have, therefore, my minus this is equals to 3s squared minus 28. So this becomes my general solution. So it's like when you are solving for definite integral. So I have found expression for c, and then I'll go back to this place, this particular place, and put the value of c that I've solved for inside there. I think that's very clear. Do you have any question? Do you have any question? Okay, so let me solve one more question on this. Let me solve one more question on this. Okay, so solving one more question. The next question I'd like to solve, let me get question quickly. Okay, here's the question. The question says, find, that's number 3, find the general solution of the differential equation dy dx of 1 plus y this. Okay, this is quite simple, sir. This one is quite simple. This one is just for you to understand some basic things. So here, what I'm going to do is to first cross multiply. So let's do that. So I have 1 plus this x and s squared dy. Okay, so that's the first thing. But then I know that this one can come under this one can come under this. So I have dx plus s squared and dy plus what? 1 square. So you can confirm. So you can see there's no error, there's no mistake at all. So you have to be very careful. So I can also express it like this and say 1 plus s squared dx 1 plus y squared dy. I guess you are following. To solve this is simple. So we put in our integral sign 1 plus x dx and then 1 plus y so dy. So to do this we have to just recall. We have to recall. You know what you have to recall now? You have to recall something. Then x inverse is the same thing as s squared 1. So the entire expression there, the entire expression here, this thing is tan x inverse plus c and then tan y inverse of y at this other side. So I can say therefore my answer is this. So this becomes. So if the value of if the initial condition or boundary condition was given, I would have solved to find C. But in this case, we are not given. So this becomes the answer. And in case you don't understand what I did here, it's actually one of the standards. For example, if you are given something like this, in mathematics, this is the same thing as yes, this is the same thing as this. So you need to know this. And if this place was if this place changes to plus and there's a minus sign, instead of it to be tan, it will now be cut. So these are standards that we need to know in integration, and that's why it's important you are grounded in integration before you can do ODE, ordinary or differential equation generally. If you're not grounded in integration, you're going to have a serious problem. In fact, you cannot do differential equation till I come your way again. Bye.